This problem is a confidence interval when sigma is unknown. So in this case, we're going to use the student's t-distribution as opposed to standard normal. When sigma is known, we use standard normal. Sigma unknown, we use student's t. Okay, so our critical value becomes a t, as shown in our equation here, and we also have a sample standard deviation, or s, rather than sigma, because sigma is unknown. Here, we have a couple of things we have to do. We have to remember to calculate our degrees of freedom. So degrees of freedom with the student's t is going to be the 251 sampled minus 1 for 250. Okay, and let's see here. The results of our sample, we're looking at prescriptions issued and the average price. Okay, so here we have $14.23 in the middle. Right, that's our sample mean. Sample standard deviation is $3. Okay, and we want to know what the critical value is if we want to determine a 90% confidence interval for this sample. All right, so with that, we take our degrees of freedom, 250. We line that up with our 90% confidence interval to find our t-value, or critical value. So in this case, t is going to be 1.651. Okay, so we would have then the 14, looking at this equation here, we have 1423 plus or minus 1.651 times 3 over the square root of, how many was our sample? Oh, 251, right. Okay, so now we need to calculate this part of the equation here, and what we come up with then is, this is going to be 3126. Right, so remember this is in dollars and cents, so that will round that to plus or minus 31 cents. Okay, so then our result becomes 1454 over here, and on the lower end we have 1392. So we can say then with 90% confidence we believe our true population mean is somewhere between $13.92 and $14.54.